Okay, welcome back. This is Engage New York, Module 3, Lesson 5. This is concept development. We're going to go ahead and start that same way that we did in Lesson 4, but we used adults and children. So if I said 3 boys subtract 1 girl, what would that give you? Well, are they the same? Are they the same? Can you subtract 3 boys? Can you subtract 1 girl from 3 boys? Okay, so how do we change the problem? Just like we changed the problem from adults and child to we changed it to people, right? So how can we change this so that they're like units? Well, how about if we just rename it as students? So what if we went 3 students subtract 1 student? That would give us 2 students, right? Okay, so hopefully you're seeing the big idea here of creating those whole like units. All right, so what can we do now? How about 1/2 minus 1/3? How is this problem the same as the one before? How is 1/2 subtract 1/3 or 1/3 subtracted from 1/2? How is this problem similar to this problem? Think about it for a second. What do you think? Well, you're absolutely correct. The units are not the same. We have to change the units to be able to say or give an answer, right? So 1/2 subtract 1/3. So let's go down here. Here's 1/2 and here's 1/3. So if we're going to use our scoreboard method to find our common denominator, hopefully you're getting faster at this and you can see where we're going. 2, 4, 6, 8, 3, 6, 9, 12, right? Oh, look at that, 6 and 6, correct? So that's going to be our common denominator. So 2 times 3 is 6. So 2, so 1/2 times 2, right, times 3. And we're going to subtract. Now we're going to go 1/3, 3 times 2, right? And now we're going to end up with 3, 6 minus 2, 6. Can we subtract now? Yes, we can. Okay, we're going to end up with 1/6. So let's take it all over here, back over here to using our idea of equivalent fractions. So here is our 1/2, right? Now we're going to multiply that by 3, right? And now how many units do we have? We have 1, 2, 3, 4, 5, 6. We have 3, 6. Remember, equivalent fractions taking up the same amount of space, but just now putting them on the same number line, right? All right. So now we have 1/3, and we're going to divide this and we're going to multiply this by 2, right? And double the amount. And now we have 2, 6. Now, this is tricky or not tricky. So what you're going to do is you're going to go over to the larger model, the model with the higher number. And you're going to take 2, 6 away from here. So you're going to take away 1, 2, and you're left with 1, 6 is left over. Okay? So that's how we're using these rectangular fraction models. Is you're going to take this number away from here. So 1/2 subtract 1/3 is equal to 3, 6 subtract 2, 6, which is 1, 6, correct? All right, now, so 1/2 subtract 1/3 is 1/6. And that's how we write it in word form. All right. Hopefully you can see the similarities between the addition and the subtraction. And now we're moving on over here. So now we're going to go 1/3 and 1/4. So what is our strategy for creating a common denominator? Oh, wait a minute. It's going to use scoreboarding, but hopefully now you're starting to catch on to those common denominators. I'm going to do this a few more times until you're getting the hang of it, and then we can just quickly choose our common denominator, because hopefully by then you're really seeing it, using what you know about multiplication to see your common denominators a lot faster. 3 times 1, 3 times 2, 3 times 3, 3 times 4, 4 times 1, 4 times 2, 4 times 3, 4 times 4. There it is. Now I'm going to take 1/3, 1/3 times 4. And now I'm over at my 1/4. Here's 4 times 3. Remember, whatever you do to the top, you have to do to the bottom, because when you use the equivalent fractions, you can see how both numbers change. So this becomes 4/12. Subtract 3/12. You're going to end up with what? That's right, 1/12. Okay, so now let's come over here to our rectangular fraction model. So I have 1/3. And if you want, we can just draw it down here. Here's 1/3. And now I'm gonna multiply it by 4. Now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 4 of 12, right? That's why we multiply both the top and the bottom, because the amount of pieces are increasing, right? The pieces are getting smaller and they're increasing, and both your numerator and denominator are changing. Now over here is our 1/4. Now we're going to multiply it by 3. So if you notice, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and we have 3 12s, right? So 1/3 subtract 1/4 is equal to 4 12s subtract 3 12s gives us 1/12. So 1/3 subtract 1/4 is 1/12. All right. Now, here's some bonus, 1/6 minus 1/5. Now notice, what do you notice? What do we call these types of fractions when the 1 is in the numerator? That's right, they're called unit fractions. So these are all unit fractions. Now, just looking at it, what do you think the common denominator would be? What would be the smallest product they both share? Would it be, so you can think 5 times 1, 5 times 2, 5 times 3, 5 times 4, 5 times 5, 5 times 6. Okay, so the denominator you're going to end up is with 30. So you would multiply by 6, and you would end up with 6 30ths. And here you'd end up with 5 30ths, and you end up with 1 30th. This one right here, 40 seconds. You'd end up with 7 40-seconds, and 6 40-seconds. You'd end up with 1 40-seconds. This one right here is 56. So this would be 8 56, and this would be 7 56. When you subtract them, they would end up with 1 56. All right, so that's bonus. That's learning how to quickly in your head recognize, number one, without having a scoreboard, what the smallest denominator would be that they could share, their least common denominator, and being able to quickly, what do they all have in common? They all end up being unit fractions, and their pieces get really, really small. All right, so we're moving on to 1/2 and 1/5. So what I'm going to challenge you with is I'm going to see how well you can map out this problem. So I've left you plenty of room to work, and I want you to scoreboard. So I want you to scoreboard, create your new equivalent fraction. I'd love to be able to see you creating a rectangular fraction model, starting off with the original fraction and then changing it to an equivalent fraction, and then solving. So go ahead and try it and come back to see how you did. Okay, so hopefully you were able to scoreboard. Choose your common denominator. 1/2 times 5/5, subtract 1/5 times 2/2. Gives you 5/10 minus 2/10 equals 3/10. Then I came down here. I started off with my half, and then I multiplied by 5 and increased the amount of pieces that I had. Then I ended up with 5/10, and then I subtracted. I came over here and I started with 1/5. I multiplied by 2 and ended up with 2/10. So then I'm coming back over to my original problem, and I'm taking away 2/10 from there, and I'm left with 3/10. All right. Hopefully that was easy and you're getting the hang of it. All right, let's go over here. Let's try number 4 together, and then 5 and 6, I'm going to have you work on and see how you do independently, and then come back to check your work. All right, so let's go back to 2/3 and 1/4. So let's go ahead and scoreboard 3 and 4. Hopefully it's coming easier for you. 3, 6, 9, 12, 4, 8, 12, 16. Oh, look at that. Yep, it's 12. So 2/3. So 3 times 4. Subtract 1/4. 4 times 3. Now my new fraction is 8/12. Subtract 3/12, which gives me 5/12. All right. All right, so 2/3. Now remember, 2/3, I'm going to now multiply it by 4. So let's go here. Let's start down here. Let's go 2/3. Let's multiply by 4. 1, 2, 3. So now I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8/12, right? And then over here, I have 1/4. And now I'm going to multiply it by 3, right? And now I have 1, 2, 3, 12. Now, so what I'm going to do here is since they are equal units, right? 12 and 12, I'm going to come over here and take away 3. 1, 2, 3 from here. And I'm left with 1, 2, 3, 4, 5/12. All right. Okay. That was your last example where you're following along with me. Now, number 5 and number 6, you are going to try independently and then come back to check your work. And yes, I do want you using the rectangular fraction model just to illustrate. You're only illustrating to me that you understand. You're keeping in your forefront, you're keeping it in your mind that when you change your original fraction to create a common denominator, you're not actually changing the fraction. You're not changing how many pieces of the puzzle you have. You're just increasing how many pieces you have. So it truly stays the same fraction. So 5/12 is the answer. Okay, go ahead and begin. Come back and check your work. All right, so how did you do? Were you able to scoreboard and find your lowest common denominator? Multiply. So 2 times 7 is 14. And then 7 times 2 is 14. Create your common denominator. 7 14ths minus 4 14ths is 3 14ths. Came over here to illustrate the fact that we're not really changing the fraction. They're still equivalent fractions. 1/2 is still 7 14ths. 2 7ths is really 4 14ths. So I created my model. Then I came over here and took 4 away, and I was left with 3 14ths. Then I scoreboarded, found my 15, did my multiplication. I ended up 4 times 3 is 12, 5 times 3 is 15, 2 times 5 is 10, 3 times 5 is 15. Subtracted 10 from 12 and got 2 15ths. Then I came over here and used my rectangular fraction model. And I colored it in with my original fraction of 4/5. Then I multiplied it by 3 because that's what I did here. Ended up with 12 15ths. Then I came over here, created 2/3, multiplied it by 5, ended up with 10 15ths. Then I came over here and took 10 away and ended up with 2 15ths. All right, so as you can imagine, the problem set is going to follow along exactly with what we just did in the concept development. So yes, you're going to draw a rectangular fraction model and write the answer and simplify your answer. So by using the least common denominator, you're going to end up with the simplest fraction. And then we are using the operation of subtraction. So what do you imagine our word problems are going to be? Yep, you got it. Subtraction. So Mr. Penman had 2/3 liter of salt water. He used 1/5 of a liter for an experiment. How much salt water does Mr. Penman have left? Easy breezy. Sandra says that 4/7 minus 1/3 is 3/4 because all you have to do is subtract the numerators and subtract the denominators. Convince Sandra she is wrong. You may draw a rectangular fraction model to help you. So you need to prove to her and show her where she's making her mistakes. Show her how to do it correctly. That is the expectation. All right, once you have completed the problem set using both the rectangular model, using the strategies that we just did, 1, 2, and 3, using those 3 strategies, come back and check your work. All right, I'm sure you'll do really well.